This video, let us solve practice number, that is practice problem 4.4, that is from Sadiku textbook. So here they are asking you to find the value of Vx using superposition theorem. So Vx is mentioned here. Okay, this is Vx. So we can by analyzing the circuit, we can see that there is one voltage source, independent voltage source. There is one independent current source, and here there is one voltage dependent current source. Voltage dependent, why? It is depending upon Vx, and here the sign is current, so it's a current source, so it is voltage dependent current source, okay, or voltage controlled current source, VCCS. Okay, so now what happens, according to superposition theorem, we have to consider only one independent source at a time. Remember, this should be left intact. Which one? The dependent source. You are not going to open this. Open means current source will be opened, right? That is in superposition theorem. That is deactivating the current source. But remember, this is dependent current source. So, you are not going to open it. Okay. So, this will be left as it is. It is kept intact. Okay. So, now I will consider 25 voltage source effect. Okay. 25 volt voltage source effect. So now what is that? This is 25 volts. This is 20 ohms. And this one will be open circuit. Okay. And here we have 4 ohm. 4 ohm. And here we have 0.1 Vx. 0.1 Vx. And this is Vx. See, if this is Vx, there is no element in between. So this one also will be Vx. Okay. This one will be Vx. So this point is also Vx now. So now what happens is, here what we will do, we will consider the current direction like this. Okay. At this node, nodal analysis will be performed at Vx. If sum of incoming current will be equal to sum of outgoing currents. So incoming current is 0.1 Vx. What is outgoing current? This one will be voltage divided by resistance. So, Vx divided by 4 plus, again, Vx minus 25 divided by 20. Here I will take LCM, that is 20. And here it is 5Vx plus Vx minus 25. So, this is 6Vx minus 25 divided by 20, 0.1 Vx. So, if I take this side, 0.1 into 20, it becomes 2Vx. 2Vx, that is equal to 6Vx minus 25. So, this is 4Vx, that is equal to 25. Vx is equal to 6.25, right? 6.25 volts. This is because of independent voltage source. Now, let us take 5 ampere current source. 5 ampere current source. So, voltage source will be shorted. This is 20 ohms. This is the current source. And here we have another resistance. Dependent source as it is. This is 0.1 Vx. This is 5 amperes. 4 ohm, 20 ohm, and this is my Vx. Again, we will be applying nodal analysis at the Vx. So here the sum of incoming currents will be equal to sum of outgoing currents. So here I'll take 5 plus 0.1 Vx, that is equal to Vx by 4 plus Vx by 20. So again taking the LCM, it will be 6Vx, 5 plus 0.1 Vx. Okay. So now we can say this is 100 plus 2Vx, that is equal to 6Vx. 4Vx is equal to 100. Vx is equal to 25. Okay. Vx is equal to 25 volts. Okay. Vx is equal to 25 volts. This is because of current source. So now, according to superposition theorem, we have to add this two, because this is because of voltage source, this is because of the current source. So finally, additivity property comes into existence now. So Vx will be equal to, since this is Vx, this is positive, this is also positive. So 25 plus 6.25, that is equal to 31.25 volts. So this is the value of Vx. Just remember, you are not going to open or short the dependent sources. Dependent sources are kept as it is while solving problems using the superposition theorem. You have to apply the open circuit and short circuit concept, that is only on the independent sources.